Good evening, everyone. I believe I can be heard. Yes, so if you can hear me, just send a comment in the chat section that you can hear me. So we proceed with what we have for today. Yeah, so just as we discussed yesterday, we are going to continue the virtual AI and machine learning training with functions and Lambda function today. So that is what we are going to tackle for today. And I believe that you guys are going to pay close attention to whatever we are about to do because this is a very, very important concept in Python. And you would really need this a lot in whatever you do. Right. So once again, I would like to welcome you to the eighth eighth session of the virtual AI and machine learning training organized by the College Caucus of the 64th KNUST SRC Parliament in collaboration with GAD Academy and in partnership with Build It. Once again, my name is Gotinenchi, the founder of Build It and your instructor for this course. So let's get started. Now, when we talk about functions, what do we mean by a function? So functions are like mini programs within your code. They allow you to organize logic, reuse it, and make your program modular and easier to understand. So think of it this way. You realize that when you were in basic school, you were taught functions as part of your elective mathematics course, right? Yeah. So let's say we have a domain, right? So let's say we have one, two, three, and we have a codomain, right? Um, okay, let me put it this way. Let me put it this way. I think that would be the best. So let's say you have a function, right? You have a function. Let's say one, two, three, and you have a domain and you have a codomain here, and you have a function here, right? F of x. Now let's say the outputs. So let's say this is the input, and this is the output, right? So in this case, you have values like 2, 4, and 6 here. When this passes through this function, it gives you an output of 2. When 2 passes through this function, it gives you an output of 4. And when 3 passes through this function, it gives you an output of 6. Right? Good. Now, if I'm to ask you, what will be the term for this function? This function actually represents 2x. So y is equal to 2x, where x represents the input values. You get it? So in this case, 2 when the input is 1, 2 1 gives me 2. When the input is 2, 2 times 2 gives me what? 4. When the input is 3, 2 times 3 gives me what? 6. Do you get it? So functions are more like it's more like a program that transforms one thing to the other. Do you get it? And you could also realize that this particular function is performing as it has a specific functionality. It is doing something specific. Do you get it? Same thing happens in Python programming. You see, sometimes you can actually do this by actually doing it one by one. Do you get it? One by one, because here we just have three input values. Do you get it? You can do it one by one and get your output. But in this case, because we can find a generalized term for the function, so that we can put in different input variables to get an output. You get it? So this kind of function simplifies everything for us. So if you have 1,000 input parameters here, this function is going to transform it into an output, into the output you are looking for. Do you get it? So that is why you can see here that functions are like mini programs within your code. They allow you to organize logic. Do you get to reuse it? So if you want to reuse the function, you can always just call it and you get its functionality. Do you get it? And make your program modular and easier to understand. Right? So the syntax is very simple. You define a function. For you to create a function, the syntax is defined with the def keyword, followed by a name, parameters, and a code block. You get it? Good. So we are going to apply this real quick. Then we see how best we can work with everything. All right. Good. So let's start with an example. Right. So we are going to start with how to define a function. How to define a function. It is very, very simple. So just like I said, you define a function by using the def keyword, right? So def. So as soon as you type def, Python interprets it as you're about to start a function. You're about to create a function. So we are going to create a simple function where, or we are going to create a simple function which would use it to greet, let's say, our users. Do you get it? Good. So this is how to create a function. Once you are done with the def keyword, you proceed with the let me check it. If you proceed with the name, so defined with the def keyword followed by a name and what parenthesis. So in this case, we are using greet. So greet, and we follow it with what parenthesis. Do you get it? Then your colon would come. As soon as you bring colon, it will automatically indent it for you. Do you get it? So this line is indented. That is, it has 4 spaces to show that it's inside the function. Right. Good. Now, what we are going to do is that we are creating a function to just print hello, welcome, welcome to build it. So we just created a simple function to do this. Right. Now you realize that when you hit enter, it is still under the indentation. Do you get it? But then we are basically done with what we are supposed to do with the function. So you'd have to leave the indentation. Do you get it? You have to get out of that indentation before you can continue with the code you want to work with. Do you get it? You are writing a code that does not form part of the function. So here, if you want to call the function, right, whenever you create a function, you have to call it, because if you don't call it, you wouldn't be able to get access to the functionality. Do you get it? So for you to call the function, you just type the name with the parentheses. So when you run this, you can see hello, welcome to build it. As simple as that. So this is how we create functions in Python. Now, in some cases, this parenthesis could take a parameter. But because there is no parameter here, we say that this is a simple function with no parameters or return value. Get it? The only thing is that you can just call the function and it gives you the output of what it does. As simple as ABCD. Now let's move on to another example where we are going to deal with functions with parameters. Right. So functions with parameters. Parameters let you pass data into a function. So you realize that this particular function, there was no parameter in the brackets. Do you get it? But in this example, we are going to take a function that has a parameter. Do you get it? And when we say functions with parameters, these parameters basically let you pass data into the function. Good. So let's say that with the same way how we created the function, realize that this is a greet function which is very general. But here we want to append the name of, let's say, a person. Do you get it? So in this case, we we use the def keyword, and then let's change the name to greet person. Open and close brackets. Get it? We are changing. The first one was greet, and the second one is greet underscore person colon. But then we are saying that we are working with functions with parameters. So we can give this greet person function a parameter of name. Do you get it? So in this case, we are passing data, the name data, into this function, right? Now, the next thing we are going to do is that we are going to print, this time around, we want a situation where we are returning hello, welcome to build it. But in this case, we are adding the name of, let's say if you are enrolling someone, do you get it? We are going to add the names of the registrants to the hello. So let's say hello John Doe, comma, welcome to build it. So this is how to work with it. Now, print, in this case, we are going to use an F string because I told you that F string gives you the functionality where you can embed variables into your string. Do you get it? So in this case, F small letter. So we've created an F string and we are saying that what? Hello. In this case, the name here becomes a variable. The name here becomes a variable because it could change with time. It could change from John to Elijah to Emanuela to different other names. You get it? So hello. So let me give full stop, comma, welcome to build it. Good. So we are done with this. So for us to kind of leave this, we want to call the function greet underscore person, right? Greet underscore person. Greet underscore person. But you realize that when we are calling this function, this particular function has a parameter. So we would have to pass the parameter in the function so that we can return the output we are looking for. So in this case, I want to replace it with what? Alice. So realize that when you call this function and you run it, it will print, hello, Alice, welcome to build it. So if you take a critical look at this, you realize that the Alice here was the input parameter. So this name here, realize that this function looks like what is here. Looks like what is here. We have the greet person and then the input parameter. Now the input parameter is what? Name as a string. You get that? Good. So this is how to work with functions with parameters, as simple as ABCD. Right? We are going to proceed with functions with return values. We are going to proceed with functions with return values. Now, we use the return statement to send a result back from the function so that it can enable you use it elsewhere. Right now, let me use an example to explain it in detail for you. So you can see something here. Use return to output a value from a function. Right. So let's say we are going to create a function that's prints out the square of a number. Do you get it? So in this case, we are going to use the def keyword to define the function. So def square. So that's the name. Open and close brackets. So parentheses. Now, in this case, because we are going to work with a number, we'll have to pass the number parameter as part of the function. So here, we can use number. You can change it to any name. You can use integer. You can use, what's the name? Figure. You can use any word, right? Good. So define square. Now, inside the function, we want to say that the result of everything is equal to the number times number, because you know that when you want to square 2 squared is the same as 2 times 2. So if you want to print out the squared of the input parameter, which is number, then it means that the result will be what? Number times number. As simple as that. But then here is the case where we would want to print the results back from the function. So when you want to send a result back from the function, you have to use the keyword return. Do you get it? You have to use the keyword return. So return, realize that once you type this, it turns to green, which shows that it is a keyword. Do you get it? So return result. Now look at what this is doing. So first, this def square number creates a variable, it creates a function that would calculate the square of the input number. Good. Now we now created a variable called result to store the square of the number, because result is equal to number times number. You get it? So in this case, if we have the number to be equal to 5, we are just multiplying it by itself. You get it? Now we use the return statement, this return statement, to send the value of results, back to the caller. Do you get it? Now I'll explain it in detail for you guys. Now let's leave the let's go outside the function and let's do something very interesting here. Now let's create a new variable called answer, and let's give it square of what? 5. Square of 5. Now let's now say print answer. Let's see what happens. Now realize that when you print answer, you get an output of 25. You get it? So what happens is that we called the square function with the argument 5 and stored the returned value in the variable answer. Do you get it? Actually, you can decide to remove this. You can decide to remove this and just run it. You still get 25. But then we just wanted to store it in the variable answer, right? So let me make this clean. Let's create an f string and let's see the square of let's try something. Let me see if I can put this here. The square of is answer. Let's see what happens. We are getting an error. The square of number is answer. Okay, so you realize that the number here is not defined. I actually did this to explain something to you. Now, the number here is just an input parameter. It hasn't been defined like how you defined answer to be equal to square of 5 or result is equal to number times number. Here, result has been defined. Do you get it? Good. So let's say let's quickly put this here. The square of 5 is answer. So the square of 5 is 25. You get it? Good. So what happens is that the return statement, you use it to send the value of the result, this variable result, to the caller. Do you get it? So what happens is that when you call it here, just like how we called the function here, when we did this, when you do this, it means you are calling the function. Do you get it? Good. So when you do this, the return result would actually, this return statement would actually send the value of this. So you see, we are returning results. So it would send the value of results back to the caller. So what happens is that it will perform all the operations and send the answer to, or send the answer after you call the function. As simple as ABC. Right. Now, there's one interesting concept in functions which is known as default parameters. And in this case, default parameters have preset values. Just if you don't provide an argument when calling the function, those are called default parameters. So functions can have default values for parameters used if no argument is provided. So here you can sometimes hear argument and parameters. They basically mean the same thing. So this could be your argument. It could also be your parameter, right? Good. So let's try an example. We are going to define a function named greet with time, right? Now, name is required, but time has a default value of morning. Do you get it? You see, the issue is that just like how we provide input parameters for functions, sometimes you want to ensure that this particular parameter is default. Do you get it? It's default. It doesn't change. It's already there. That is it. That is what stays. Let's quickly look for the meaning of default. Okay. In computing, it describes what happens if no other choice is made, often referring to preset options in software. So let's get this right. Default describes what happens if no other choice is made. Good. So if no other choice is made with our parameters, say that this is equal to this. That is what we are trying to do here, right? So let's quickly define the function. Define greet with time. You guys remember that I taught you guys how to name your variables. If they are separated, you separate them with underscore. So in this case, we have parameters like name, we have time to be equal to morning, and our colon. Now, when you do this, it is just like what we did here. But in this case, you realize that the number here could change. We can actually change this input parameter to 8. And when we say the square of 8, we are going to get our answer of 64. But here in this example, we want to say that time is always equal to morning. So when you want to bring in default parameters, you set it equal to, you bring the equal to, and you set the value to it. As simple as ABCD. So let's see what happens. Print f string. Let's create an f string. So let's say we want to say good morning. So we want to say good morning. So here the variable is what? Time. So you put it in curly brackets. Good morning. And then you take in the what? The name. The name is also a variable. You get it? So in this case, when you are calling the function, let's say greet with time. Let's say greet with time. Let's give it a name of Benito. Now when you run this, you ran into an error. So I made a mistake with the greeting. Good. So you can see good morning Benito. So in this case, the time has gotten a default value, which is what? Morning. So whatever being the case, whenever you have time as part of the function, it would always return morning. As simple as ABCD. Right. Well, now let's try something different. Assuming I remove the equal to morning here, and I run this, I would, yes, I would have to add the time, just like how I structured the function. So the name and the time. So let's put the time here. In this case, let's use evening. Let's use evening. So when I run this, I would get good evening, Benito. As simple as ABCD. This is how interesting Python is. So you bringing the equal to and setting a default value of morning. Even if you bring evening here, it will still, hey, what am I doing? What am I doing? We are still having, evening. Maybe I run a cell twice or something like that. But let's remove the, yes, good morning. So in this case, we set time to be equal to what? Morning. The reason is that we know that, let's say the time is static, right? Let's say the time is static. Do you get it? Good. So let's say you build a row call app, and the row call app, usually when your workers log in, they usually log in the morning for row check, for row call. Do you get it? So in that case, the time would have to always be static. So good morning, good morning, good morning. So you don't have to change it. You get it? So when you set the time to be equal to morning, there's no need to add it as a parameter when you're calling it. You get it? Interesting. So that is it. We have another concept also known as the multiple parameters with return values. Multiple parameters and return values. So functions can take multiple inputs. Functions can take multiple inputs and return multiple outputs for complex tasks. So functions can take multiple inputs and return multiple outputs for complex tasks. So now let's do one example. So let's say we are going to define a function, and what the function is going to do is that the function is going to add two numbers and multiply those two numbers at the same time. Do you get it? So here we can create a function, define, add, and multiply. Define, add, and multiply. And we are working with what? We are working with two numbers. So we can give them A and what? B as the input parameters. Right? Now, what are we trying to do? We are trying to say that this function should add two numbers and should also what? Find the product of it. So we can say that sum underscore results is equal to A plus B. Do you get it? And product, so let's say product is equal to A times B. Now, what happens is that in this case, we would have to return whatever the function would do to the caller. Because if you don't return it, it would not bring the output of the operation when you call it. So in this case, you would have to return the operation that you did. And what operations did we do? Sum results, and what? Product. So when you do this, whenever you call the function would perform the operation and give you the output. You realize that here we didn't use any return statement because we were just printing out something to the console. We weren't really having some operations we were working with. Do you get it? So in this case, we didn't bring the return statement. But here is the case we are performing an operation, right, which is attached to sum underscore results, and another operation which is attached to product. So once we are done with everything in the function, we'll have to use the return statement to what? Send the output of the operation when you call the function. Atula bubbles. I like this topic. Let's continue. So let's get out of our function and let's see something. Now, realize that here we are performing two operations. So you can define two variables. So let's say total. and product. So total and prod 2. Right. Now, for you to make this work, you would have to call the function add and what? Multiply. Add and multiply. Now you have to provide your input parameters. So let's say 5 and what? 6. Now, the reason why I had two variables here is because the total variable would be set to the first input parameter, and the prod will be set to the second input parameter. So whatever operation that was being done for the first one will be what? Sum result. And whatever operation that you did for the second one will be the what? Product. So you would have to ensure that you structure your function in order. Else, if you mix things up, you get mixed results. Right? So now let's use an f string to say let's use an f string to say the sum is, in this case you have to use what? In this case you have to use total. This, you get it, because we set the total to this. So sum is what? Total, comma, and the product is in this case it will be what? Prod. These are the new variables. So prod. When you run this code, you get, so the sum of 5 and 6 is 11, and the product is what? 30. As simple as ABCD. So in this case, you've created a function that adds that has the capability to add two numbers and to multiply those two numbers as well. So if you change it to 100 and 789, it is going to give you the output. And this is why functions really helps you. You realize that here I said that functions are like mini programs within your code. They allow you to organize logic, reuse it. So you realize that with the same function, we are reusing it to add and multiply two different numbers. You get it? And make your program modular and easy to understand. Good. So that is what this function does for you. Guess what we have next? A practical example, which is known as the temperature converter. So we are going to create a function to convert Celsius to Fahrenheit. So this is a practical example, and I would entreat you all to pay close attention to whatever I'm about to do, because it's really going to help you in the long run. Right. So let's define a function called Celsius. Let's define a function called Celsius to Fahrenheit. I'm hoping I don't spell this wrong. Fahrenheit. Good. Now, in this particular example, we would need an input parameter, because the whole point is that we want to convert Celsius to Fahrenheit. So the input parameter will be Celsius, because that is what we are focusing on. We are converting all Celsius values to Fahrenheit. So here, the input parameter will be what? Celsius. Right? Good. Now, we have to write the formula to calculate Fahrenheit. Do you get it? Now, you know that the formula for Fahrenheit is Celsius times 9/5, all in one bracket, plus 92. Do you get it? Good. So let's create a variable called Fahrenheit, and let's set it to the formula. So Celsius times 9/5 plus 32. Now, note that here I didn't change the variable name. I still maintain the Celsius, because I know that that is my input parameter. Do you get it? Now, this is an operation, so we would have to return the what? The Fahrenheit. Would have to return the Fahrenheit. You get it? Good. So let's say that we have a variable that takes the temperature, right? So in this case, we create a variable called temp underscore c, and we set it to, let's say, 25, right? Now, we want to convert this temperature, which is in, let's assume it is in Celsius. That is why I did it temp underscore c. So this temperature is in Celsius. So for you to work with the temperature in Fahrenheit, what do you have to do? You don't have to retype this whole formula again. You just have to call this function. Do you get it? You just have to call this function and put in this as the input parameter, because this is what contains the 25. Do you get it? So you call the function Celsius to Fahrenheit. Celsius to Fahrenheit. And what will be the input parameter? The input parameter here is temperature underscore C. That is holding 25. Do you get it? So temp underscore C. So when you print temperature in Fahrenheit, you get the output of 77.0. Do you get it? But we are programmers. Let's make this very clean. We are going to use f string to add the units to it. So let's say f string, please, it's not g string. Interesting, interesting, interesting. Now let's continue. Don't mind me, sometimes I can just go hi-fi and stuff fully. Right? Yeah. So let's say f string. I told you that f string gives you the capability of you adding variables to you adding variables to your string. You get it? Good. So in this case, we will say that, yeah. So in this case, okay, let's say a temperature underscore C, because that's what is that's what is holding the this one. So degree, um degree Celsius, degree. Mm, let me quickly copy something here. I want to make this one degree Celsius. I just want to copy this text. Okay, so I just want to copy this and add it to the string. All right, so this in degree Celsius is another variable. So here we match it with what? Temp underscore F. Degree what? Fahrenheit. Let me see if I'll see degree Fahrenheit here. Degree Fahrenheit. Degree Fahrenheit. Hey, symbol na I always the symbol is okay. Let me copy this. Paste it here. All right. So when you run this, you can see 25 degrees Celsius is 77.0 degree Fahrenheit. Let me check if my answer is correct. 25 degrees to Fahrenheit, degrees Celsius to Fahrenheit. Yes, the output is 77. So you see, we are right. I took my SHS mathematics very well. All right. Interesting. So at this point, this brings us to the end of today's session on functions. And I have some keynotes for you guys. I'll share the Jupyter notebook with you. So once you are done, you can just go through. There are also exercises here, right? Let me clean this wall for you so you know how to work with it. Right. Good. So this brings us to the end of the tutorial on functions. Now, we are going to move on to the next concept, which is a very, very, very interesting concept in Python, which is known as the Lambda function. Please, the Lambda function is very, very important. When we get to machine learning, the data analysis part of everything, we are really going to apply it a lot. So I'd want you all to pay close attention to what I am about to teach. And I believe that in the long run, it would help you exceedingly, abundantly, left, right, center, backward, forward, everywhere. Right. Now let's move on to Lambda function. Interesting. Now, what is Lambda function? Lambda function in Python. Lambda functions are small, unnamed functions defined with the lambda keyword. They are ideal for short one-off operations where a full function definition is unnecessary. So let me quickly use an example to explain, because we've seen a lot of words here, but then I know that once we jump in with examples, you are really going to understand it very well, right? Good. So let's proceed with what we have. Now we are going to create a basic lambda function. We are going to create a basic lambda function. Now, the goal is to define a lambda function and assign it to a variable named triple. The lambda keyword, we'll use it to create the function, and we'll use x as the input parameter and an expression having x times 3. Now, what the function is supposed to do is that the function is supposed to multiply its input by 3. So if x is equal to 4, the function should return 4 times 3, which is equal to 12. So this is very, very simple. Now, let's do this. So let's create a variable name called triple. So triple is equal to lambda, when you use the lambda keyword, lambda x colon. So this is the syntax. Lambda argument colon expression. Do you get it? Lambda argument colon expression. So this is the lambda. What is the argument? I told you that argument and parameter, input parameter, we use it interchangeably. So this is the lambda keyword. This is the argument, or this is the parameter. Do you get it? And now move on to the expression. What is the expression? We want to triple it. So x times what? 3. So this is how we create a basic lambda function in Python. Right? So this is the lambda keyword. Lambda keyword. This is the argument. This is the argument or the input parameter. You get it? And this is the expression. This is how to create a basic lambda function in Python. As simple as ABCD. Right. Now let's proceed with what we have. Let's proceed with what we have. Now in this case, we want to triple the number 4, or we want to triple the number 10. Now let's create a new variable called results. If you want to work with this, you know that this is a function because it contains what? A lambda operation. So this becomes a function. So you'd have to call it. So triple. Now this should take an input parameter, an argument of x. So x is the input parameter we are working with. So in this case, we can put 10 here. Okay, let me just use 20. Now when I print results, realize that my output will what? 60. Do you get it? So what happens here is that I created a lambda function with this simple operation. So what I'm just trying to do is that I just want to triple any input parameter I set in the code. Do you get it? So when I change this to 90, it will solve it for me to 270. Right? So this is how simple lambda function is and realize how best it works. Do you get it? Good. Now let's try another example. We are going to work with lambda with multiple arguments. So you realize that this one had only one argument. You get it? So we are going to work with lambda with multiple arguments. So we are going to handle multiple inputs in a single expression. Interesting. Interesting. Right. So we are going to create a lambda function that multiplies or that finds the product of two input parameters. So in this case, it is very simple. Let's create a variable name called products. Now in this case, we are going to use the lambda keyword, and we said that what? The expression is simple. Lambda and what? The arguments. Lambda followed by arguments. So in this case, we are working with multiple arguments. So we can say x, comma, y. Then we bring our colon. Then it will follow with the expression. What is the expression? X times y. That is all. So let's say we set result, or let's say answer to be equal to products, of 6 and 7. Now we are going to print the outputs. We are going to use f string to print an interesting output here, and this is it. The product of 6 and 7 is, we are going to put in this. That will be the final answer. You get it? So answer. So this function will basically multiply 6 times 7 is what? 42. As simple as that. So this is an example where we have lambda with multiple arguments. Simple as ABC. Now we are going to look at another one which is called lambda with map. So you use the map function to apply a lambda function to every item in a sequence, like a list. So you realize that when we were working with loops, we said that with loops you can iterate over, when you're using a for loop, you can iterate over a sequence like a list. Do you get it? So here in lambda functions, the map would allow you to use your lambda function in every single item in the sequence. Do you get it? So let's create a variable called even numbers. So even numbers is equal to, we are creating a list, so squared brackets 2, 4, 6, 8, and what? 10. Now we are going to create a lambda function, right? That would we are going to create a lambda function that would double let me give a better example. Okay, so we are going to create a lambda function that would double each and every item in this list, right? Good. So in this case, what we will do is that we are going to create the variable called doubled, right? Now we said that actually when we create when we are creating the lambda function, we type the lambda keyword with the what? The argument. In this case, we are working with one argument. It's not like we are working with a lot of arguments. It's basically more like an iteration over the sequence. So you can give it 1. Now we are trying to what? Double it. We are trying to double it. But this is what happens. This lambda x colon x times 2. What happens is that it will take each number x in the list, right, and double it. Now, for us to make this work, we would have to add the map, we would have to wrap it around the map function so that it would apply the lambda function. You get it? So that it will apply the lambda function to every item in the sequence, to every item here. So in this case, we'd have to wrap this around the map function. So map colon. I believe that is clear. Good. So here what happens is that actually when I print, let's see what happens when I print double. When I print doubled, I'm getting an error. Map must have at least 2 arguments. So you realize that this map, although we wrap it around the lambda function, it is basically taking this as one input parameter. Do you get it? So here we can bring a comma because you say that the map must have at least 2 arguments. So comma and what? Numbers. So let's add another parameter called the even numbers. Because the even numbers, you see, the thing is that the map function, let me confirm this. Map function in lambda. Okay, so the map function in Python is often used with lambda to apply a function to each item in an iterable. So an example of an iterable is a list or a tuple. The lambda function allows you to define a small anonymous functions inline. Good. So here, after we pass in the lambda function, we'd have to also pass the iterable. In this case, the iterable is the what? Even numbers. This is what is storing the list. So when you run this, what do you get? You get map object at this. This is the output you get. But then the problem is that you would have to return it in the form of a list. So you'd have to convert this object into a list using the what? The list function. So wrap this around the list function and you get your output. So you realize that 2 has been doubled to 4, 4 has been doubled to 8, 6 to 12, 8 to 16, and 10 to 20. This is how interesting lambda function is. Right? All right. So the next one we have is lambda with filter. So you use the filter function to select items from a sequence based on a lambda condition. Do you get it? So let's say you have a sequence, but then you want to select special items within that sequence based on a condition. Use the filter function to do that with the help of lambda, right? So let's define a list called numbers. And then let's set it to a list 1, 2, 3, 4, 5, 6. Okay, 6 is enough. Now, we are going to use the filter function with a lambda to keep only odd numbers. To keep only odd numbers. To keep only odd numbers. So in this case, when you are creating the lambda function, it will be something like this: lambda x colon. Now you now bring the expression x modulo 2 not equal to 0. So let me quickly explain this to you guys. I taught you conditional statements. I told you that when you are creating a lambda function, you type the lambda keyword, you bring the argument, you bring a colon, and you now bring the expression. So in this case, this is the expression we are going to work with. Now, we are saying x modulo 2 not equal to 0. Do you get it? So what happens is that this operator is not equal to. So if I take any input parameter, or if I take any argument, so let's say 6, and I divide by 2, if it is not equal to 0, then it means that it evaluates to what? Odd numbers, because whenever you divide odd numbers by 2, so let's say 3 divided by 2, you get what? 1. Remember what? 1. Do you get it? So if x modulo 2 is not equal to 0, then it means that we are actually working with odd numbers. As simple as that. Now, we are going to create a variable called odds. And this odds is going to filter the odd numbers in the numbers list. So for you to work with this, let's set this to odds equal to this. But then we are saying that we want to select special items within this list. Do you get it? So we would have to use the filter function, because the filter, let me search it here for you guys to also confirm. What is the use of filter function in Lambda? Okay, so the filter function in Lambda, what does it do? What does it do? What does it do? Copilot is delaying. Okay, so the filter function in Python is used to filter elements from an iterable, like a list, tuple, or set, based on a condition. When combined with a Lambda function, it allows you to define the filtering condition concisely and apply it to the iterable. Interesting. So in this case, we'd have to wrap it around the filter function, right? Good. Now, not forgetting the fact that when we work with this, it would return the object, the first object. So we would have to wrap it around the list function as well. Get it? Yes. So wrap it around the list function. When you wrap it around the list function, you can now proceed to work with what you have to do. So print odds. Hey, this one is not odds, sports betting. This one is odd numbers. Hey, I'm getting an error. Power expected 2 arguments, but got 1. Don't forget that when we were explaining this particular example, we got that same error. And we said that the map function takes 2 input parameters. So the first one being the lambda function, and the second one being the iterable. So in this case, what is the iterable? The iterable is numbers. So we bring comma and we add numbers. When I run the code, I'll get my output. I have an output of 1, 1, 3, 5. Good. Interesting. Wow. I love Lambda functions. Lambda functions help you create very simple functions, but then they perform very high and complex tasks. Right. This is so interesting. Right. Now let's move on to Lambda for sorting. So we've done Lambda with map, Lambda with filter. Now let's do Lambda for sorting. Now you use a Lambda for custom sorting with sorted. Sorted. So now let's use an example to digest this into the lowest particles we have on Earth. All right. Now we are going to define a list of tuples. This is not just a list. This is a list of tuples called pairs. So let's say pairs is equal to, we are creating a list of tuples. So within the list, we have tuples. So 1, 1. So this is the first pair. Another pair is 3, 3. And then another pair is 2, 2. Right. So we've created a list of tuples. Now um each tuple is like the tuple contains an integer and a string, right? Okay, so it's more like a paired data. So 1, 1, 3, 3, 2, 2. Good. Now we are going to use the sorted function to sort the list with a lambda as the key, right? So hmm, hmm. how do we go about how do we work with this particular example? How do we work with this particular example? Okay, now let's create a lambda function. So lambda, and then let's create a lambda function. Let's give it an argument of x, and let's say x1. Good. So if you take close look at this, realize that when I was teaching you how to access elements in lists, tuples, and all those things, I told you that when you have something like this 0, 1, 2, 3, right? Okay, let me say 7, 8, 9, 10. 7 has an index of 0. So that Python works with zero-based indexing. So 8 has an index of 1, 9 has an index of 2, and 10 has an index of 3. You get it? So what we are trying to do here is that this lambda function will take the input argument. That it will take the argument x, and it will now return the value at the at the index of 1. Here, what's the index of 1? This is index 0, this is index of 1. Index 0, index of 1. Like when you're working with it based on each element in the list. Do you get it? Good. So here we take the x, do you get it? And then we return its objects at the index of 1. So all these are, so you see this tuple is considered as one value, one item. But within this tuple, there are two elements in it. So this one has an index of 1, this one has an index of 0. You get it? Good. So what we are going to do is that let me quickly delete everything here. Right. Good. So what we are going to do is that we are going to create the we are going to create we are going to use the sorted function to sort the list with a lambda as the key. So for you to work with this, let me comment this out. Okay. So sorted pairs is equal to the sorted function. You get it? The sorted function, and it will take two parameters. So the pairs and then the key will be equal to the key will be equal to the lambda function. So one thing about the sorted function is that the sorted function, just like the filter function and then the map function, it takes two arguments. But then the for the arguments of the sorted function, it would first take the iterable. So this is the iterable. The iterable is the list we created here, which we stored in pairs. Do you get it? And now it would take another argument, but that argument we would have to set it to a key. So the key, we set it to what? Lambda to this expression. Now, let's do something. Let's print sorted pairs. Let's print sorted pairs. So when you print sorted pairs, Um, okay, I'm encountering a little problem here. Let's quickly do a research. Uh, what does the sorted function do in Lambda? Good researching is also part of the of your programming skills. Sometimes you can run into an error and then you might not know what to do. So sometimes you have to know how to research. So this particular error we are encountering is called semantic error. The code is running, we are not getting an error, but then it's not getting what we actually want. Do you get it? So let's look at what the sorted function does. The sorted function in Python is used to sort elements of an iterable like a list, tuple, or dictionary in ascending or descending order. When combined with a lambda function, it allows you to define a custom sorting key. So the key is what we set to the lambda function, enabling more complex or specific sorting criteria. Here's the breakdown. So sorted, the iterable, the key, right? And let's add. Okay, so here's the syntax. So the iterable here we used was pairs, because pairs is a list of tuples. Then we now move on to the key. The key was set to the lambda function. You get it? Now let's try and add reverse. Let's try and add reverse based on what we saw here. Let's say reverse to be equal to false. Let's set to be equal to false. Let's run it and see. Let's set this to true. Okay, so it's, you see, if we reverse it, I don't know why, but it's, I think the output. Okay, let me set this to true. 1 3 2. Okay, cracked the code. So what happens is that it arranges everything in alphabetical order. Do you get it? So 1 T, we have T here, we have T here, but then in alphabets we have T here, we have T here, we have O here. Now O, letter O comes before T. Yes, MNOP, OP, QRST. Good. Now we move on to T. Now we have T here, we have T here, but then H comes before W. That is why you have this in this form. So this one will actually sort it. It will actually sort it in alphabetical order, but then this 3 will come before 2. So if you set it to the reverse of it, so let's say reverse to be equal to true, it means that you are setting it to in the descending order. You get it? Good. So that is how to work with it. I was a little bit confused when it comes to the main function, right? Good. So let's solve one practical example, then we end today's lesson on functions and lambda function. So we are going to apply a discount to a list of prices using lambda. Good. So let's say we create the variable called prices. Create a variable called prices. Then we give it the prices we have, 100, 50, and 25. Good. Now we're going to create a lambda function. Discounted is equal to. So in this case, we create the lambda function. Let's use P, letter P. So lambda P is P times what? 0.9. That is the discounted price. So the discounted price is more like if you have, let's say, 100 CDs, right? The discount, and we are giving a discount. So 9/10. Right. So like this is the expression we are using. Right. Let me quickly Let me quickly clear this. All right, so this is the expression we are using for the discounted price. Now, in this case, we can't just work like that because we have an iterable here. Now, when you have an iterable, you quite remember that I taught you guys that when you have an iterable, there are two functions that you use. It's either you use map or you use what? Filter. In this case, we are going to use map because the map function allows you to apply a lambda function to every item in a sequence. So because we want to work with every price in this sequence or in this iterable, we are going to wrap it around the map function. Now, what did I tell you about the map function? I told you that the map function takes two arguments. So the first one being the lambda expression and the second one being the iterable. So prices, you get it. But then if we are to print this, it's going to return a map object to us. It's going to return a map object to us. So we'd have to wrap it around the list function. You have to wrap it around the list function so we can actually convert this into a list. So the discounted price when we are to work with 0.9 for 100 is 90, 50 is 45, and 25 is 22.5. This is how interesting lambda functions is. You see, lambda functions helps you to work with ease. See, sometimes you don't have to define a whole function to do something complex, right? So lambda functions are small. You see, they are really small, unnamed functions. So lambda functions are usually unnamed functions because realize that the first functions we were working with, we were actually naming them. So this one like this, the name of the function is add and multiply. Get it? So lambda functions are small unnamed functions defined with the lambda keyword. They are ideal for short one-off operations where a full function definition is unnecessary, right? So the key points, lambda function is limited to single expression and is often used inline. So realize that this we are just working with one expression, just single expression, right? So at the end, what do we have? We have keynotes and exercises, right? So this brings us to the end of today's tutorial on functions and lambda functions. Now we are done with Python basics, and our next session we are going to start with machine learning. I hope to see you in the next session because we are gradually entering to something very, very practical because this is the point where we are going to apply the concepts we learned in Python basics to build machine learning models and to make great analysis using Python, great data analysis using Python. So once again, thank you very much for participating in today's lesson. I hope to see you tomorrow where we are going to proceed with machine learning. Thank you very much. Have a nice day.